Hello, can you hear me, Manol?
Yep.
Good afternoon, everybody, and thank you for joining us. Happy New Year. I'm joined by Manol Bajani. Apologies for the delay and the issue getting started today. And it looks like we're up and running. So it's been quite an eventful week for us, eh? At least the last several weeks, and especially for you guys as a team. Why don't you give us some insight into what's happened? And for the minority of people that may not know, this week we launched our alpha mainnet, and which is now live. We had some hiccups with it. We had the interface go up and down, but we did mention that there were some bugs that we have ironed out over the course of this week, and I'm sure more bugs will crop up that we will work on. But nonetheless, Manolo, why don't you fill us in? What has the last several weeks been like for you? What have you guys done? What have you gone through?
So, there's always this joke in our industry that tech failed at the last minute, right? So here we are, maybe, what was it? I think 3 weeks out from release, and we're seeing, oh, we're not getting reliable message delivery, right? So, well, how do we fix this? We only have 3 weeks left, right? So we're testing and all this stuff. And eventually it got to the point where we ended up switching libraries. So for those of you guys who have looked at our GitHub, you know that we're using OpenDHT for communication. We ended up switching to a library written in Go called Smudge. And this was a gossip library that we implemented to hopefully solve the communication problem. And in the meantime, we were in talks with OpenDHT, trying to get this issue resolved. So the clock is ticking, and we're testing a completely new library, which, mind you, we had to write C bindings for because it's a library written in Go. So it's actually not designed to run with C++ programs unless somebody codes it to do that. So we have somebody writing the C bindings, and then other people are actually testing the library to see if it works with that program. And in the meantime, we're getting updates from OpenDHT on this sort of communication problem that we're having. And eventually we thought, okay, well, maybe it's because the messages that we're sending across the network are too big, right? So we're using UDP for messaging. UDP is fast, and it's considered an unreliable protocol, but it's really fast because it doesn't have kind of the overhead of the TCP protocol, right? So we thought, okay, what if the problem is that the messages that we're sending are too big, right? So we started fragmenting our messages. This was new code that we implemented, right? So we break the message down into smaller messages, and then as they arrive at the receiver, they get reassembled by the node that's supposed to be receiving those messages, right? And then we thought, okay, so we can do even better than this, right? How about we leverage the capabilities of OpenDHT, use it for what it's good for, right? So what we then decided to do was send notification packets to the receiver node that says, there's a packet that's waiting for you. It's got this nonce, and this nonce we're identifying as just the packet identifier, right? So every packet that we generate has a nonce, which for those of you who aren't familiar with it, a nonce is just like a unique identifier for anything, right? So the receiving node receives this nonce value and is told to go and fetch its message from OpenDHT. And that was the solution that we ultimately, yeah.
For our non-technical viewers, what is a nonce? I'm sure many people have heard nonce mentioned. A nonce is used in Ethereum to ensure uniqueness, if you will, of your transactions, and so forth, right? So what is a nonce, and how are we using nonces?
Yeah, so you pretty much covered it when you said it identifies uniqueness, right? So if I generate a nonce and then somebody else generates nonce, those two nonce values are going to be unique, right? So it's a way of uniquely identifying something. And it can be anything. It can be a combination of letters and numbers. It can be just numbers. It can be just letters. As long as it's sufficiently unique to where two parties will never generate the same nonce in such a manner to where they will collide and cause duplication problems and this that. So that's pretty much all a nonce is.
And I think in Ethereum's case, they use nonces to as an incremental number to distinguish between your transactions, so that your transactions are unique. But there is just it's 1, 2, 3, 4, 5, if I'm not mistaken.
Yeah, so
in the case of
there's
submitting
an
a transaction,
incrementer, but it goes up, per, I believe it's per account, right? So every account on Ethereum has its own nonce,
right?
And that nonce is just an auto incrementer value. But
Indeed.
even by doing that, they're able to keep their transactions unique, right? Because if I send a transaction and then I send another transaction, those two transactions have different nonces.
Right.
So that's how the network is able to identify. So that's pretty much what a nonce serves, is a unique identifier.
Okay.
So our packets, we embed them with these nonce values. And that way, all we have to do is just tell the receiver node that, hey, there's this packet for you. It has this nonce value. Go and fetch it. Now, the good thing about these notification messages is that they're really, really small, right? So the problem you get with UDP is as the messages get bigger and bigger, there's more of a chance of you losing that message, right? And that message will never get reset because UDP doesn't reset anything. So what we thought then is, okay, what if we keep the messages extremely small, right? To the point where they're small in the order of just bytes. So maybe one message is no more than 10 bytes, let's say. And that has given a near guaranteed delivery of these notification packets, which just contain the nonce, and then the receiver reads that nonce, and they're able to go out and fetch their message. And that's how we ended up ultimately solving the communication problem.
And in solving this communication problem, we also reduced the latency in the network. Is that true?
Yeah.
So communication, correct. We've got near instant delivery of messaging, right, of messages.
Yep. So the problem we run into now is, this is what it was, maybe 2 weeks before the deadline at this point, if I remember correctly, right? So we had lost a little over a week in development time, getting this communication problem sorted out. So it was definitely a busy last few weeks for us. Many sleepless nights, recovering the time that we lost in trying to get the rest of the network tested and, to a point where we were comfortable releasing.
Yeah, I think that there was a week lost in just in testing, right? As in, because we first thought the problem was something that, that's the core functionality of some of our nodes. And so we were testing the core functionality of our nodes to find out if there's something that we're doing that's causing these messages to be dropped. Then I think we spent another week switching out, right? OpenDHT, trying Smudge, and then we came back to OpenDHT. So we spent, at least another week there, and then there were the modifications that you just mentioned, essentially introducing replies and acknowledgements to the on top of UDP, as well as the fragmentation of the packet that you talked about, as well as reducing the size of that packet and simply sending notifications of messages rather than the actual messages themselves. And that took another week. So in total, the time that it took to solve this problem was about 3 weeks. And on the very last day, we're still there testing that communication and making sure it's where we need it to be. So yeah, I mean, it was extremely intense on you guys, and what I want to say to you and the team is, I know the community are very grateful for everything that you guys did. You gave up Christmas, you gave up New Year's Eve, you gave up New Year's Day. You worked throughout that entire period. So I'm extremely grateful to for what you've done, and what your team has done. And I know that the real investors, the real token holders, are grateful too. So thank you, Manoa.
You're welcome. I mean, the thing is, ultimately, we promised to deliver. So we had to keep that promise, right?
Yeah. So some people wonder, why has the network been released with bugs? We got to a place where the network was functional, and we made the decision to release because the network was functional. And we did say that it's not bug free, and that's simply because of the lost time solving a major bug, a very serious bug. Now, some people have asserted that we've deployed nothing but an interface that's come from a template that we got from somewhere, and that's the sum total of the Sparkster decentralized cloud. How do you respond to that?
I would say to those people, go look at our GitHub.
But I mean, is there? I can understand such a statement, right? I mean, someone looks at the network and they see an interface, and the interface is there sometimes and not there some other times, and there's information that's missing, for example, if you look up the blocks or if you look up the transaction. So I can understand the statement, and I can understand that there's really no way for them to observe the network yet. So what are your thoughts on that? I think that there's some valid criticism, right? There's some valid criticism with regards to the interface. I accept that, and I think you do too, right? What are your thoughts on that?
Yeah, I mean, the interface itself could definitely use work. I am in agreement there.
Where was the majority of our efforts focused?
The thing is, our number one priority was in functionality, right? We wanted to make sure that this thing was working the way it was supposed to. And I just spent, quite a bit of time outlining one of the biggest problems we had, right? So these were the kind of things that we were facing, and keep in mind the clock is against us at this point, right? So it was definitely a bind that we were in. So obviously, when you're in that state, number one priority is functionality, right?
No doubt, no doubt. And we've delivered a functional network. So let's walk through the network. I'm just gonna open up a diagram of what this network looks like, and maybe you can walk us through what the network does, Manoa.
Yeah. So we have 3 nodes on the network. We have the master node, the compute node, and then the storage node. And each of them essentially does what its name implies it does. So when you send off a transaction request, suppose you want to execute some function, this request is sent to the master node to begin with. Now that master node is then responsible for coordinating that transaction, right? So it's going to be the one that calls up the compute node, and the compute node is where your code is actually going to get executed, right? So this is important because it's not the master nodes that are responsible for actually executing the code that you tell them to execute. It's the compute node. And the master node is working with the compute node to eventually get the results of that code verified and sent off to the storage node to be committed to the data store. So the storage node, its responsibility is for filtering data. If I want, let's say a piece of data that says something like, give me everybody who lives in Saj's favorite state, California, and who's under the age of 35, right? That would be the storage node's job to go out and pull that information and ultimately deliver it back to whoever needs it, right? So the storage node stores data, the compute node is the one that actually executes your code, and then the master node is the one that's responsible for verification and consensus and all that good stuff.
Yeah, the verification nodes perform verification and send. So just to go into a little bit more detail on what you said, right? In terms of the mechanics of how this works, a transaction is sent or a request is sent to a master node from an external client or from the interface that we've deployed. That hits the master node and comes down, and the master node that it hits, because there's 21 of these master nodes in any active group, chooses a compute node, as Manal said, to execute the code. It receives a request to execute some function. The compute node then goes to the storage node to fetch that function, to come back and execute it. And at the same time, the verification nodes, each other master node, so if there's 21 master nodes and one master node receives the request, that master node replicates that request across the other master nodes. And the other master nodes select verifiers of this transaction. They too go and get that piece of code. Now everybody's executing that code because we don't know if we can trust this compute node, right? So because we don't know if we can trust this compute node, we have 21 nodes executing that transaction in parallel. One's the compute node, the others are the verifiers. Now, the output that's generated, you've got input, you've got input, process, output. The process is the code, is the function itself that's acting on the input data that produces an output. We hash that output and we send the hash back to the master nodes. And what the master nodes do is they see, do we have more than 2/3 majority on each of the responses that on each of these transactions, meaning that each verifier is coming back. Each verifier is coming back to the master node and sharing that information with the master nodes about that particular transaction, but the hash of that transaction. And because the hashes would match, right? Because they hash that same output, then we can easily arrive at consensus on that transaction, right?
So I think here we should talk about this concept of hashing a little bit, if you want to go into that.
Yeah, that's a good idea, actually. Why don't you elaborate on what hashing is and maybe give your thoughts on it?
Yeah, so when you're talking about blockchains, many times you'll hear this term hashing, right? So we covered one of the points, which is a nonce, and hopefully you guys are familiar with that now.
A unique number is a nonce.
Yeah. So the hash is it's a fixed size string of letters and numbers that gets generated off of a message that's fairly large, right? So I can take a message that's really, really big and I can compute the hash of that message, and it turns out to be maybe, I would say, 30 to 50 characters long, depending on what hashing algorithm I'm using. Now, the important thing here, why are we using hashes instead of actually sending the function output back to the master nodes, right? So the function outputs could be extremely large, right? Suppose you've written a function that says, I want you to get me a list of all the countries in the world, right? Well, that's going to be a very big list, right? When you hash it, you get a value that's very small, relatively small, to the actual function output. Now, when you send that back to the master node, number one, you reduce load on the network because you don't need to transfer all that data. And number two, when the master node goes to compare that hash, right, all it has to do is just compare a 30-character string to another 30-character string, instead of having to compare maybe a 2,000-character string to another 2,000-character string.
Or 10,000 or whatever it might be, something substantially larger if you're looking at the list of all countries. And so, and then, it essentially gets written to a block, and that block gets committed to the storage node, right? And that's the process of a transaction. So there is an article that's released today by a blog called In Code We Trust. And it's been suggested that what we've built is very simple. And not only is it very simple, we didn't build most of it, that we copied and pasted and took the vast majority of it from other places. Now, I do want to say that I think the guy who wrote that blog, Jerry, I think he seems like a reasonable guy. I think he seems like a nice guy, actually. And I don't think it's anything personal that for him to hold this opinion. But maybe, Manolo, you can share your thoughts on his opinion of the code. Is it factual? Is it accurate to say that the vast majority of the code that we've published is not our code, and that we have in fact taken it from elsewhere, and that we've done very little to build this network? Is that true?
So for anybody who's looked at our GitHub, you'll see that there are many thousand of lines of code in the GitHub repository, right? I would estimate that about 100 or less lines of code is code that we've adapted from somewhere else. And this is the beauty of open source technology, right? At the end of the day, if somebody's done something which is well documented, why reinvent the wheel, right? In fact, we're using many open source libraries in our project. We use OpenDHT, which is fully open source. We use WebSocket++ for WebSocket communication, right? Instead of having to roll our own DHT solution, our own WebSocket solution, we're using open source solutions that have existed. In the case of WebSocket++, I think as far back as maybe 2006, right? So these are libraries that they're tried, they're tested, they're proven to be correct, right? So why go and reinvent something that has already been done and proven?
Yeah,
right? It saves development time.
My thoughts on this are that if you look at his previous reviews and his other reviews, I don't think that this is an impartial review. And I say that, I say that because if you look at his other reviews, he talks about the build process, he talks about the type of machine he's used and what his experience was like of that build process. Other projects have been praised for using open source libraries. We seem to have been criticized for using open source libraries. There is very little or no mention of what the build process was like for building our project. I think you'll find that our build process was smooth and flawless. And so, what other projects have been judged on and what other projects have been praised for, we've either not been judged on or we've been criticized for. So, all I can say is I don't think that I think that the opinion that he's presented represents the opinion that he's held since we released the first code release. It matches exactly what he's stated publicly, and that's that. And frankly, he has the right to an opinion, and we respect that. So it is what it is. But we obviously don't agree. Another point is that to suggest that this is standard, right, and that not only did we not build this, which obviously we did, right, as Manolo has said, we've lifted of the many thousands of lines of code, maybe 100 of our source code that we've released are from another project, which we have attributed to that project. It's clearly stated in our code that it's come from this source or that source or whatever. So we don't claim it to be our own. Secondly, as you can see from just the picture of this network, let alone the code implementation of this network, there's nothing simplistic about this. So for example, one of the things that we've implemented is the way that voting works, an autonomous voting mechanism for voting these master nodes into this active pool, right? It should be noted that today, Ethereum doesn't have such a method, for example, for solving, for operating in a safe way without using, they're still using proof of stake, for example, right? I'm sorry, what am I saying? They're still using proof of work. They haven't yet switched to proof of stake. They're looking at the end of 2019 to achieve proof of stake. The voting is one of the #1 problems that people have with EOS. it's the biggest concern that people have with EOS's network. We've implemented this today. It's in our code. I think Jerry somewhat alludes to this in his review. So, well, what are your thoughts on the idea that what we've built is very basic? The code that we've implemented is very basic. You mentioned to me that you think that there's a certain aspect of our project that he has not looked at, blockchain core in specific. What are your thoughts on that?
Yeah, so that was one of the things that stood out to me. Through all this, there was no mention of the common library that we've written called the blockchain common.
Blockchain common, right?
Yeah, so if you look at the three nodes, the master node, the compute node, and the storage node, and you look at the main function in each of those nodes. So again, for those of you who are not technical, every program, every executable program that's written in C++ and many other languages have what's called a main entry point into that program. And this is defined by writing a main function, right? So when the loader loads your program, the part where it enters your program is through that main function. This is how it knows where the execution of your program actually begins. So if you look at the main function in each of these programs, in each of these nodes, you'll notice that it's very simple, right? But if you dig deeper, if you go into blockchain common, which is this library that we've written, which is shared among all three nodes, you'll see that there's actually fairly complex code, right? And we've done that on purpose to abstract away all the details from these individual nodes. We put it into blockchain common so that what happens is if we want to update something later down the line, all we have to do is update blockchain common. We don't have to rewrite this behavior 3 times in 3 separate nodes.
Yeah. Cool. Okay. Give me a second. There were some questions I received that I wanted to get to. So, did we release a functional network, Manal?
Did we release a functional network?
Yeah. Was the network that we released on December 31st functional? Could people execute? Could people execute functions and execute things on this network?
Yeah, and that was the whole goal of this project, right? That on the 31st, we will be delivering to you guys a functional network.
Yeah.
Now, will it have problems? Yes. I mean, it's an alpha, right? But, was it functional? Yes, definitely.
Okay. Okay, cool. So another question I've received, right, is that we're using templates to build our interfaces, our UIs. Why do we use templates? Why don't we make our own?
Maybe you can speak to that a little bit.
Yeah, I can. So we use templates because that's not where the core value that we're bringing is. The core value that we're bringing is in the design of the network, the functioning of the network, how the network does what it does. And that's where we're focusing our efforts and our resources. So if there's a way to be able to be efficient, right, with interfaces and such, I don't see anything wrong with doing that. And so of course we use templates. It's like using an open source library, right? Why reinvent the wheel if someone's already done it for you? So it's a matter of efficiency so that we can meet objectives and in a timely manner. It's, I don't think that those things are at this point in time core to what we are delivering, right? They're, for example, an interface to what we're delivering. Yes, we could have done a better job with this, and we take responsibility for that. I take responsibility for that, and we acknowledge that, right?
I think ultimately, though, it's as you said, right? It's the functionality that matters in the first go round. So if you look at the tech behind the scenes, it's pretty powerful stuff, right?
Yeah.
And
So
I think that's really what people should be focusing on more. I mean, yeah, the interface could do with some work, but that says nothing to the actual tech running behind it.
So someone is saying a question that we've received. Why are the transactions on the site not even real data from the mainnet? They are fake data. Anyone can copy and paste this. There's just a pre-test net that couldn't even be up consistently. So what do you say to that? Do we have any fake data? Are we manipulating anything? Have we? I heard a funny assertion from someone that suggested that we're picking up images from some image site and populating that as a transaction or something along those lines. What are your thoughts? Are we pulling wool over their eyes, and is this all fake?
Well, so we've got like a Sparkster Santa Claus now just grabbing images from no, these are real transactions happening in the network. I mean, unless somebody injected something by the time I left, I haven't seen anything fake going on in the network at all.
So someone claims to have copied our interface, and then they claim to have found some suggestion that we faked stuff. I'd recommend that the people who've received such a message to look at the screenshot. The screenshot says that the data is coming from stream.sparkster.network, right? What is stream.sparkster.network? What does that do, Manoa?
That's where so we have this thing connected with our blockchain API, if you will, for lack of a better term, and that's where that's hooking up to.
So what stream.sparkster.network does is it collects data from the network and then spits that data out to the interface. It's the intermediary between the interface and the network itself. To suggest that it's called stream.sparkster.network. So, what else can I say?
So that data is coming directly from the blockchain itself, actually going to the interface.
Yeah. So there's been some questions about documentation, right? Why don't we have documentation for the network, and so forth? So the first thing is, guys, we worked our tails off to get this out on December 31st, right? There were people that hadn't slept in 3 days to get the network out because of the delays that we had, as we've mentioned at the beginning, the issues that we had at the beginning. So the network was released. Documentation is coming. Well, when can the community? So what are your thoughts on documentation? What sort of documentation are you working on? When might we be able to get this out?
Do they mean documentation in terms of how to use the network? Because you see,
I
look at this from the developer perspective, right? So is there developer documentation? Yeah, there already is. So which documentation?
I don't think they're talking about the developer documentation, which indeed we've released, right? I think they're talking about like a user guide or something that they can that gives them instructions on how to use the network.
Oh, I see. Okay, so like what the account IDs and stuff are and all that stuff.
Yeah, and how to construct the functions and so forth.
Yeah, I mean that should be coming. What would you say, Saj? Maybe in a couple of weeks max.
Yeah.
I think.
Yeah, agreed.
Because we are definitely working on it. It's just a matter of polishing it up, stuff like that.
Exactly. Someone has said that that they've not been able to run a node, meaning that they don't know what to connect to, and we've not provided the documentation on what to connect to and such. So that will be coming as part of that documentation, so that you'll be able to spin up your own nodes and join our network. I mean, this is not a test net. You can run those nodes, and you can spin up those nodes and connect to the network. Maybe we can provide some of that sooner rather than later.
Right. So I can speak to that briefly. If you are interested in running your own node at the moment, you can definitely set up a private network if you want to, by bootstrapping your nodes to one another. And if you put in, so at the command line, if you send --help as the command line switch, you will get a list of commands on how to bootstrap your nodes and stuff like that. You can definitely do that for the time being if you want to.
Okay. Okay. So can you explain the code deployer and executor? Can you explain what does that mean and what does it do?
Sure. So the code deployer takes the function that you provide to it. I think they provided like a multi-line text box on that page, right? So you put your code in there, and it'll get saved to the network to one of the storage nodes.
And this is JavaScript code, right? So you write some functions in JavaScript, right? And then you can save those from that, from that interface. Go ahead.
Yep. And then what'll happen is you'll get in response a function ID, right? This is a unique ID that identifies your function on the network. So then when you go to, what is that option? Not code deploy, but the other one, function executor.
Right.
When you go there, then that's where you enter your function ID, right? That same function ID that code deployer gave you, you enter there. And
with your input parameters.
Yeah, so there's something else here that I want to highlight. Some of you might be wondering, well, on the function executor page, why is it also asking me for my private key, right? And the reason it's asking for both your public and private keys. The public key, obviously, so the network can authenticate that it's actually you that's sending the code. But the page itself needs a private key to actually generate a signature for that function ID that you're sending along, right? So that private key doesn't actually get transmitted to the network. It stays local, but that page itself uses your private key to generate your signature. So that's why it's asking for both pieces of information.
Okay, cool. So what part of the Sparkster decentralized cloud mainnet is operational? So we talked about master nodes and verification nodes and compute nodes and storage nodes and master node pools and master node voting and compute node pools and all of this stuff. What part of and consensus and what part of this is active today?
Everything.
Everything that's in this diagram is active today. Very good. So in this mainnet, we have one storage node, one storage cell, right? In future mainnets, we'll have multiple storage cells. So the obvious question is going to be, what's the TPS of the network? And maybe it's further down the list here, but let me speak to that. So TPS is, let's talk about TPS and what TPS is across the different parts of the network. The bottleneck in the network, as with anything, is where the data is stored, as with any network, which is here, right? So receiving or ingesting transactions into the storage network, we have consistent results of more than 4,000 transactions a second. Now that's ingesting it into memory, right? At more than 4,000 transactions a second on very low spec equipment. You're talking about a 2-core machine. Committing that to the storage node, which means committing it all the way to disk, right, is well over 1,000 transactions a second. So the network is in spec from that perspective. In terms of this tier here, the compute and verification tier, well, these all work in parallel. So there's no limit on, there's no limit on what these might achieve because there's nothing for them to communicate back and forth. The more you add, the more transactions that can be processed in parallel with no limit at all, right? So unlimited TPS in this tier. And the TPS that we've tested here in the master nodes is north of 6,000 transactions a second. And with some optimization that we're working on, we think we can easily get to north of 10,000 transactions a second. And how that's the case, and that, by the way, that's per node, right? Per master node. And how that's the case is because this is all running in memory. In fact, the vast majority of the network runs in memory, which is why it's so fast, right? The only time we actually commit stuff to disk is down here in the storage tier. So that's the current status of the network in terms of TPS. When will the Sparkster mining app for cells be available as described in the white paper? That will be later in the year. You know, we're going to bring the network up. We're working. Our priority is to work on use cases from this point forward, and then we'll be expanding this into mobile nodes. But you know, today you can go to our GitHub. I think the GitHub needs to be updated, but when the GitHub is updated, you'll be able to download the code and spin up those nodes. You can spin up the nodes as they are today, but I don't think the communication bug has been fixed in that version of what's on GitHub, right?
Correct. Yeah, the next push that we do will contain the code that we're actually running on our network at the moment, where the communication issue has been resolved.
Yeah. So, you know, our question here is are any of the nodes on the GitHub deployable? Will they connect to the mainnet? Kind of. They are deployable. You can run your own private network. We'll provide documentation very shortly in the next coming days, and we'll update the GitHub in the next coming days for you to be able to then run those nodes and connect to our network. A few days, and we'll make that happen. Okay, let's take some questions. I'm not seeing many questions. Maybe I'm missing them. There's a lot of talk about you, Manoa. Someone thought you'd fallen asleep. Nutter is saying, honestly, why are we going over all these technical issues? We only care about whether this current mainnet release is what the team wanted to release. And if it's not, why the decision was made to go ahead with the current release. Is this mainnet release what we wanted to release, Manoa?
In terms of everything we said it would do, yes, it is. Exactly.
This network does exactly what we said it would do. It's exactly what we promised the network would do, and it does what we said it would do. It has bugs, but that doesn't mean that we shouldn't release. It's an alpha. I think that bugs in an alpha are acceptable. Nata wants to know, can we define what functional means? What's functioning?
Well, it's as we said before, right? Everything is functional. You know, you had the master nodes talking to the compute nodes, and then their data gets saved to the storage node and stuff like that. So the whole flow works beginning to end. And that's personally what I think of when somebody tells me something is functional. Well, does it actually complete a full cycle from beginning to end? And our network definitely does.
Okay. How, again, Nutter is asking, how does he validate the functionality? I think the answer is simple. We've answered this already. You can write a JavaScript function. You can deploy that JavaScript function. It'll spit out a function ID. Then you can execute transactions against that function by providing your own input strings, and it will generate an output for you.
So I interpreted that differently. That when he said, how do we validate the functionality, I'm thinking more of like internal validation. So for that, we have written test cases. And if you look at the GitHub, you'll be able to see the different tests that we've written to validate the correctness of the network.
This is another good point. You can run the code and see that the tests pass. How many people have contributed nodes? Why is the Explorer not showing TPS? What is the current TPS? So we've answered what is the current TPS, but it's a very good question. Why is the Explorer not showing TPS? It's important to understand what that gauge shows. What the gauge shows is the number of transactions that have arrived in 1 second and been processed. If there's no transactions arriving into the network, then the TPS is 0, right? As transactions arrive into the network, you'll see the TPS rise. It's the number of transactions that have arrived and been processed in 1 second. So that's why. And how many people have contributed nodes so far? We've not provided instructions on how people can contribute nodes. This will be coming out very shortly. Nutter says that it's a diagram on the back of a napkin. Well, thank you for your feedback.
It shows a testament to your artistic ability set. By the way, I didn't draw that picture. I just want you guys to know.
Nikita says it'd be good to see a demo on the screen. I don't have anything ready to demo right now, but we can certainly do that, next week. Actually, next week I'm in Las Vegas, so the next time that we're on YouTube, we can certainly do that. But what we can also do is we can provide a quick article that gives you essentially some code that you guys can go away and execute yourselves independently of what we're showing you. Maybe Manoa, you can put something together quickly to do that.
Yeah, we'll see if we can get something done.
Yeah. I think we've spoken about, so William is copying and pasting from the article. We don't agree with the claims of this article. As the picture on a napkin, as Nutter has said, demonstrates, this is a sophisticated network. And the code that we've released, the product that we released at the end of the year, does everything that this network shows, right? We've talked about, signatures in the transactions that are sent. We've talked about, the different levels of consensus. We've talked about hashing the transactions. We've talked about the voting process. I don't see what's simple. So if you tell me what's simple, I'm very interested to know what you consider to be simple. As for the other stuff, as I said, I think that the article is biased. I don't think that we've been held to the same standards that other reviews have been held to. Like I said, the article doesn't go into, for example, the build process, or doesn't go into those sorts of things. The article, criticizes us for using open source libraries, but suggests that it's a good thing on other projects. So, I mean, I'll leave it up to you. So I think that's the end of what I have to say about the article. As for the napkin drawing, how would you like to see the network? I mean, you guys can test the network. How about that? And you can look at the code.
Next time we'll draw it on a piece of construction paper.
All right, we'll leave it there because I'm seeing a lot of repetition really. Okay, guys, thank you everybody for your time. I think that we've provided a complete response to the vast majority of the questions that have been asked. And if there's anything else, we'll catch you in the next AMA. Thank you very much, everybody, and talk to you soon.